igcse Computer Science Paper 2 1 2019 Winter. For each of the four descriptions in the table, place a tick in the correct column to show whether it describes structure diagram, flowchart, or library routines. First one, a modeling tool used to show the hierarchy of a system, correction of standard programs available for immediate use, a graphical representation used to represent an algorithm, a graphical representation to show how a system is broken into subsystems. So for the first one, a modeling tool used to show the hierarchy of a system, that is a structure diagram. It basically shows the structure. Look, a graphical representation shows how a system is broken down to different subsystems, but also at the same time it is a modeling tool used to show the hierarchy of a system. So it's like the same thing. It breaks it into subsystems and shows the hierarchy of the system. That's a structure diagram. A flowchart is a graphical representation used to represent an algorithm. So, flowcharts have those shapes and is a graphical way to show an algorithm. It's the same as an algorithm but in a graphical form. And library routines, standard programs available for immediate use. So you can use them anytime you want. And you can use them immediately, and they're already stored programs. Examine the following pseudocode: input A all the way to input L, and T equals to A plus B plus all the way to L. So how many are these? These are 12 inputs. So what this does is, in the end, it outputs the average equals T, which is the total of these, over 12. So it outputs the average. That's what it does. Inputs a series of values, finds the total, and prints out the average. 3 marks. Inputs the values, adds them, finds the total, and prints out the average. Describe how the pseudocode could be altered to allow any number of values to be input. So it could be changed in a way so that any number of values can be input. So it could be changed as for example, in the beginning the user inputs how many values you want to enter, and then you enter that many values as a count, as a for loop, for count 1 to user input. Example, I'll show you. So use of loop structure allow input to define the limit of the loop. So you input the limit of the loop, then you keep a counting total. You keep a count of the number of values, and you keep a running total. So for example, like in the beginning you enter value for, it's called user input, and for counter 1 2 0 to, or 0 to user input, to repeat that many times, and you keep a count of the number of values, and the end you just divide the total by your user input. So there's an example here, you have to rewrite it. This is the example. You input counter limit, I said user input, but this is called counter limit. So for loop 1 to counter limit, 1 not 0, in if you're saying in range, then 0 to counter limit. But here, and there's no in range, it's just a 1 to counter limit. And then input a number. The input is called a number. You keep a running total. You do it that many times as you stated first in the counter limit, and then when you finished the number of for loops, you output the total, which is the running total, over the value you put in first. So this is a trace table, and we have to complete this for this algorithm using this input data. So the first loop is going to be 0 0 5 58, 58, and then after input value, and then it checks yes yes yes, then pass marks 0, so this 0 would become 58. So as you can see, 58, and index is increased by 1 because value is more than 50, so index equals to index plus 1, and it adds 1 to the index, and the count increased by 1, and this time it's 40, so the index doesn't increase because it's not more than 50, and it keeps on going until it reaches when it reaches 75, it will increase index, and count will increase 1, and you enter the value. The value 82 is in the program currently, and index is increased by 1 as over here, but the next count doesn't happen. So this finishes, then number passed is printed. The index is, so this number index is printed. Number passed 5. Okay. So the purpose of this algorithm in part A was to store numbers greater than 50 in an array. This is the array pass marks, and number of times pass marks have been met, which is index 5, and find the number of outputs it, and find the number of pass marks, outputs number of times pass marks have been met. This one's easy. Table is car range. Okay, and car model, body, this has 3 options. How many doors? That uses this or this 3 options: petrol, diesel, or battery as fuels. Identifier for a specific car, so a unique ID. Oh, we can fill this over here. It would be let's see. So car ID, it says show suitable field names. So a suitable field name could be car ID, model, body style, doors, and fuel type. Car ID could be ID 07. Model could be Apollo or Pegasus or Cupid, as they are written over here. This or this, and body style could be this or this. Doors, for an example of doors could be like 4 doors or 2, or these. Fuel type could be, an example could be batteries, petrol, or diesel. So an appropriate primary key would be car ID, because it doesn't, you won't find it in any other car. Just a specific ID for every car is unique. so which contains unique values to identify each record. This query by example, using petrol and display only the car models and number of doors. So car, fuel type, all of these is in the table car range. Model, doors and fuel type, these two are checked, and fuel type is equal to this petrol, and model is ascending because it says in alphabetical order of car model. Thank you.